In this video, I cover tab changing of the transformer. So why we need to use these tab changing procedures? Why we need to use the tab changing procedures, and what are the methods of tab changing? So generally, there are two types of tab changing uh, methods is used. One is offload tab changing, changing of the transformer. Another one is on-load tab changing of the transformer. So offload of the offload tab changing of the transformer means, look at this one. This is the transformer. This is supply to the transformer, and this is the load. So offload tab changing nothing but we need to disconnect the load. We need to disconnect the load, and we need to change the tapping position, and again then we need to connect the load. Nothing but in the absence of load, we need to change the tapping position. For example, primary side primary side we have tappings like this, and this is the input side. This is at the bottom. If you want to connect this is tapping position 1 2 3 4. If you want to change, presently working at one position, the load is available here. And if you want to change the tapping position from 1 to 2, then we need to disconnect this load, and we need to change the tapping position from 1 to 2. So nothing but in the absence of load, we need to change the tapping position. Tapping nothing but these are the connection points. These are the primary connection points, 1 2 3 4, like that. Tapping positions will be available. So if you connect that this for example, if you provide the tapping position here, we will get to 240 volts. If you provide here 260 volts, if you provide the tapping here, we will get 280 volts, like that. At the different positions, we will have different types of voltages. To produce the different types of voltage levels, we need to use the tapping positions. So generally, why these tap changers are used? Let us take an example. uh, for example, this transformer secondary winding is available. From the secondary winding producing, I'm taking for example 250 volts. 250 volts it is producing. Now the loads are connected. For example, loads are connected, and at the load end we are receiving as 210 volts. 210 volts. And now as load increases, the 210 volts again will be reduces to 205 volts. Again, if you increase the loads, inductive loads, the voltage will be drops again to 204 volts, 202 volts, to 200 volts, like this. I think, but if you connect more inductive loads, the voltage at the load end will be reduces. And with low voltage, the loads draws more current. Because of this one, the appliances will not give the accurate performance. For example, if the fan is rotating at 1000 rpm, this is actual speed of the fan. And at the low voltage, the speed of the fan will reduces to 750 rpm. For example, I am taking nothing but like this. At low voltage, the electrical appliances, whatever the appliances available at our home, those appliances performance will be changes. So that to avoid such a problems, we need to use the tap changing of the transformer. As we know all that N2 by N1 is equal to E2 by E1. So from this one, I'm taking as a from N1 by N2 is equal to E1 by E2. So from this one, I'm taking N1 is equal to N2 into E1 by E2. So look at this one. As we as we increase the number of turns, look at this one. Uh, Induced EMF at the primary also increases. If we decrease the number of turns, nothing but tapping position. For example, here number of turns will be like this. For example, we have 100 turns, and at this middle position, 50 tapping position, this is 100 tapping position, this is 0 tapping position, 0, 50%, and this is 100%. Like that, we have different types of tapping positions will be available. 1, 2, 3, 4, 5, like this. So as we change the tapping positions, we can change the voltage. We can increase the voltage or we can decrease the voltage. If the loads increases, automatically voltage drop will be increases, so that we need to increase the tapping positions. Like that, if the load decreases, load end more voltage will be available, so that we need to decrease the voltage by changing the tapping positions. So next one is the on-load tap changing. On-load tap changing of the transformer. On-load tap changing is nothing but in the presence of load. In the presence of load, in presence of load, we need to change the. We need to change tapping position. Tapping position without interrupting load. Without interrupting load, nothing but if you connect nothing but in the first one, offload tap changing, nothing but we need to disconnect the load, and then we need to change the tapping, and we should connect the load. We need to give the supply to the load. Because of this one, the reliability of the supply will be reduces. Reliability of the supply will be reduces, and electrical appliances performance also reduces, so that the load consumers will feel more inconvenient. For example, if the labs, for example, if the computer labs is available without backup supply, nothing but without backup supply, if the 50 students are working in the computer lab, if the power has gone, then again they will restart the system. So there is a lot of procedure. They feel very inconvenient. So that to avoid such a problems, we need to use on-load tap changing, nothing but without disconnecting the load. We need to increase the tapping position, and we need to give the sufficient voltage to the consumers. So this is the on-load tap changes. Let us discuss in depth, in brief, uh, about the tap changing positions. So we need to take two important considerations in the tap changing. So during the tap changing, definitely this tap changing is provided high voltage side to overcome the arcing problems. Nothing but sorry. So high voltage side, we need to use tapping positions. So like in the high voltage side, we will provide more tappings, one, two, like that, more high voltage, nothing but more number of turns, and high voltage, nothing but low currents. If you change the tapping position from 1 to 3, if you change the tapping position from 1 to 3, this is 2, for example, I'm taking, this is 3. If you change the tapping position from 1 to 3, then during this process, arc should not produce. Even though arc producing, that must be very less. That is possible only with if you provide the tappings at HV side only, because HV side low currents are available. So that if you change tapping position from 1 to 2 or 2 to 3, whatever it may be, so during the process, arc production will be very less. That's why we should use this tapping. Tapping should be provided. Tapping should be provided HV side to overcome the arcing problems. Arcing problems. If you provide the tappings at LV side, then if you change from low LV, nothing but low voltage, less turns are available, so that the cross section area of the turn is more. So that if you change tapping position from 1 to 2, then LV is nothing but more current. LV is nothing but low voltage, nothing but more current. So that more current, you are changing from 1 to 2, then more current will should change. So that arcing, sparking will be takes place. So that to avoid such a problems, we should use tappings at HV side. And also, tapping is provided the primary winding, that must be provided the primary winding to avoid load fluctuations. Load fluctuations, which means this is primary, this is a primary winding, and this is secondary winding. Here loads are connected. Here loads are connected. If we provide the tappings at the primary side, 1, 2, 3, 4, like this tappings, 5 tappings. So this is one position and this is two position. If you want to change from 1 to 2 position, this transformer reactance, as we know all that this transformer is highly reactive device, primary having reactance, secondary having reactance. If you provide the tappings at primary side, due to the high reactance of the secondary winding and primary winding, load will not get any fluctuations, nothing but disturbance in the supply, disturbance in the supply. If you connect the tappings at secondary side, if you connect the tappings at the secondary side, look at this one, these are the tappings, this is 1, 2, 3, 4. If you want to change from one position to two position, this tapping is provided only for the secondary side, so that the reactance of Sex2 only is present and which is directly connected to the load, so that if we change the tapping position, the load performance also changes. For example, if the speed of the fan is rotating at 1000 rpm, then if you change the tapping position, suddenly the speed will be changes. Nothing but jerk operations will be takes place at the load end. That's why we should use this tapping must be at the primary side. These are the basics we need to remember. And how this voltage will be changes. So this is based on the this formula transformation ratio. So now let us discuss offload tap changing. This is very easy. Offload tap changing, nothing but this is tapping position 1 and this is tapping position 2, this is 3 and this is 4. And if the presently this is tapping position is available at the second position and the load is connected here, load is available and load voltage is very less. So that if you want to change the position from two position to one position, we need to disconnect the load and we need to change the position and we need to connect the load. This is the procedure of for off-load tap changing. I think, but in the absence of load, we need to change the tapping position so that sparking, sparking will be avoided. Sparking and load fluctuations will be avoided by using this offload tap changing. But because of this one, reliability of the supply and continuity of the supply to the load will be decreases. This is a disadvantage with this offload tap changing. So the next one is on-load tap changing. On-load tap changing. So this is on-load tap changing. While doing this on-load tap changing, we need to take two important points and we need to remember two important points. The first one is load circuit should not be broken. So on-load tap changing, load must be available. So load circuit should not be broken to avoid arcing and prevention of damage of contacts. Nothing but while changing the load, we need to avoid the arcing and prevention damage of the contact. So, for example, this is the contact here, and during the unload tap changing, load is available, so that during the changing of the position of the tapping position from 1 to 2, 2 to 3, whatever it may be. So, arc, if arc produces, then automatically the contact position will be damages. So that uh, we need to take precautions while designing the on-load tap changing. And the next one is no parts of the winding should be short circuited while adjusting the tap. So while adjusting the tapping position, no part of the winding, whether it is LV winding or HV winding, no part of the winding should not get any short circuit. So in this way, these are the considerations we need to take while designing of the on-load tap changing. These are the precautions we need to take. So the next one is this is the on-load tap changing transformer. What is the procedure? This is not a normal procedure of off-load tap changing and disconnect the load or changing the off-load position, tapping position and connecting up the load. This is off-load tap changing procedure. This is very easy. But in the on-load tap changing position, on-load tap changing transformer, there is a different procedure is available. So here, this is a reactor switch, reactor 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 switch here, nothing but a reactor position. This reactor is used to reduce the load fluctuations and the sudden change in current. So this reactor is used to reduce the sudden change in current and to reduce the arcing problems. So this is the reactor position. These are the reactors. These are the reactors are used. This is the diverter switch. This is the diverter switch. This is the diverter switch. And one, two, three, four, like that. These are the selector switches. Selector switches. Nothing but the tapping positions. So first of all, let us see the procedure of making this on-load tap changing. The first one is procedure. First step one is open the S nothing but selector switch. We need to disconnect the switch S. We need to disconnect the switch so that if we disconnect the switch, these reactors to pick up the current. This reactor will pick up the current. And now close switch 2. Close the switch 2. Actually, this is selector 1 will be in closed position, and this is in open position. This is 3 also in open position. So we need to close these two tapping position. And now presently actually this is available only. This is one is closed, 2 and 3 are open. Now we need to open this switch. Next we need to change the tapping position from 1 to 2, so that we need to 2 must be closed, and then we need to open the one position. We need to open the one position, that is the third step. And then final one is close the switch. Close the switch. Finally the closed switches will be only S and 3 only. So these reactors does not allow the huge current while closing the switch 2 or switch 1 or switch 3, whatever it may be. While closing the switch, these reactors doesn't allow the sudden changes in current through the second or first or third switches. So again, if you want to change the position from 2 to 3, switch must be opened, then third must be closed, second must be open, again S must be closed. This is the procedure is involved in the on load tap changing. This procedure is involved to reduce the load fluctuations and to avoid the arcing problems, and also to avoid the damage of contacts. Nothing but this is the contacts. So this is the procedure for on-load tap changing of the transformer.